Okay, this is an example on how to identify a quadratic sequence. And once we've identified the quadratic sequence, actually find an equation for its general term. And then using that general term to find other terms within the sequence. Now, my method for doing this is very straightforward, and it's important you take on board and pause the video from time to time and think about what I'm doing and making sure you understand each step. Whatever you do, don't try and run through this video all in one go. So the first thing I do when I'm analysing quadratic sequences is I write the terms vertically. So 1, 8, 23, 46, and 77. Now I'm going to introduce you to some notation. See, Tn is the algebraic notation for the nth term, which isn't particularly very helpful. But when I write it like this, what's T3? And basically that is term 3. And what's T5? Term 5. Therefore, if I go back over here, this number 1 is term 1, the 8 is term 2, the 23 is the third term, the 46 is the fourth term, and the 77 is the fifth term. So that's a very simple way of looking at the notation, and it makes life so much easier. Now, what do we do when we have a sequence of numbers and we want to find out whether it's a linear sequence or a quadratic sequence or a cubic sequence? Well, we look at what's called the method of differences. So over here now, what's the difference between 7 and 8? And the answer is, well, there's only 7 in the difference. And so that's easy enough. So what's the difference between 23 and 8? And the difference between 23 and 8 is 15. And what's the difference between 23 and 46? Well, the answer is it's a difference of 23. And what's the difference between 46 and 77? Well, 77 minus 46 is 31. Now, this is called the first difference. And on this first difference, what do we notice? The first difference, well, the numbers are all different. So the first difference, what do we got? We have no common difference. They're all different. They're not common. They're not common. And if they're not common, it means it's not a linear. We've seen that before earlier on in the course. It's not a linear sequence. Okay, that's done. So if the first difference is not common, that means we go on to have a look at the next set of differences, the second difference. So what's the difference between 15 and 7? And the answer, of course, is 8. Again, take your time. What's the difference between 15 and 23? And the answer is 8. What's the difference between 23 and 31? And the answer is 8. So this is called the second difference. And what do we know about the second difference? We know they are common. It's common, means that they're the same. They're common. They're the same. What does that imply? Well, if the second difference is common, then we can now say we have a quadratic sequence. And if we have a quadratic sequence, we now know the formula. Now you need to learn this formula, and it's called the nth term formula. So therefore we know that this is a quadratic sequence, so we have to write it in quadratic form. So it's going to be a on n squared plus b on n plus c. Now you need to learn this formula. And if you do not learn this formula, and it's not given to you in a test or an exam, then it quite simply means you will not be able to do the question. So it's absolutely essential that you learn this formula off by heart. Okay. So that's the first part of the problem done. How to identify a quadratic sequence. How do we identify a quadratic sequence? Very simple. The second difference is common. And because the second difference is common, it is a quadratic sequence. And you need to learn that. So for a quadratic sequence, the second difference is a common number. Or you can just say is common. That's acceptable. Another word for common is a constant number. Now we have to move into finding the nth term. So we're back to using the formula which I've asked you to learn. And the formula that I've asked you to learn is this formula. Tn is equal to a on n to be squared plus b on n plus c. Please learn that formula. Now what we're going to do now is we're going to use this formula to find an algebraic version of term number 1. Now because 1 occupies this position here, it means n is assuming the value of 1. So what I'm going to do is I'm going to use the empty bracket method. So wherever I see the n, I'm actually now putting an empty bracket. Now, I'm going to do this for the next two terms. I'm going to do it for T2 and I'm going to do it for T3. So therefore, it's the same. It's empty bracket to be squared plus b empty bracket plus c. Now, and then the last one is going to be a empty bracket squared plus b empty bracket plus c. Now, feeling a little bit guilty, to be honest, because ideally I would have preferred if I had a gap between each one. So I'm hoping that you haven't copied anything down yet, because I need to create a gap between each one, and you'll see why in a few minutes. It does actually make the work slightly easier in terms of setting out. Now here I go back to what I said a few moments ago. I chose the number 1, and that number 1 is occupying the position of the n, which means where the n is now a 1 in the empty bracket. Here the position that's reserved for the n is a 2. So therefore, wherever the n was is now an empty bracket. See, we're employing the empty bracket method. A 2 goes into each of those. And then finally, we've got the 3, and we put a 3 in there and a 3 in there. And once again, we've used the empty bracket method, which we've seen on a few occasions already. And that is term 1, term 2, and term 3. Now I'm going to calculate the difference. Now, if you noticed up above, I chose to use the color blue for the first difference. I'm going to use the same color again. Actually, I'm not. I apologize. I've just realized I need to actually work out the neat version of this first. In fact, each and every one of these. So what is 1 to be squared? Well, 1 to be squared is 1. So it's going to be 1 squared is 1, so it's 1a, a1, 1a, so I've got 1a here. And then I've got b times 1, which is going to be 1b. And here I've got plus c. So I've got that written in there, so I've tidied up the answer. I'm keeping it as tight as possible for neatness sake. So now I'm going to here. Sorry about that. So now I'm going to here where I have actually got the 2, and I've got 2 to be squared, and 2 to be squared is 4. And it's a times 4, which I am going to write as 4a. And here I've got b times 2, which I'm going to write as 2b. And then I've got the plus c at the very end. And now I'm on to the third one. And the third one, that says 3, and it says 3 squared, and 3 squared is 9. 3 squared is 9. A times 9 can be written as 9a. And then I've got b times 3, which I can write as 3b. And then I've got the plus c at the end. So that's the neat version of term 1, term 2, and term 3. Now, when we're doing the analysis of sequences, we find the differences. So what's the difference between 1a and 4a? So what's the difference between 1a and 4a? And the answer is very simply, it is the difference between 1a and 4a is quite simply 3a. What's the difference between 1b and 2b? Well, the difference is purely and simply 1b. What's the difference between c and c? Well, there isn't any, so it's 0. And now we're going to do the difference here. Difference between 4a and 9a is 5a. The difference between 2b and 3b is 1b. And the difference between c and c is 0. So that's the first differences. And as you can see, they're not the same. One is 3a plus 1b, and the other one is 5a plus b. The other one is 5a plus b. Just want to do that slightly neater. 5a plus b. So now I'm going to go to the second difference. And the second difference I'm doing in this sort of brownish colour. So what's the difference between 3a and 5a? Well, the answer is 2a. And what's the difference between 1b and b? Well, there isn't a difference, so we just leave it as 0. And now I've finished doing the method of differences. Now, this next bit is really, really important. It's a positional comparison. That's the best way of describing it. Now, this is the algebraic representation for term 1. This is term 1. And up here is the numeric representation from term 1. So these two circled objects in black are equal to each other. Now, this is the first differences, and this is the top of the set of first differences. And if I go back to the original table, these numbers here are the first differences. These numbers here are the first differences, and at the very, very top of the first differences is the number 7. So therefore, I know that 7 is now equal to 3a plus 1b. And you can see this is going down in a diagonal, and this one here is going down in a diagonal. So it's also, again, another way of looking at the positioning. And the last but not least, we are now looking at the second difference level, and that is the very top of the second difference level in my algebraic form, and this is the very top of my numeric second difference column. So I now know that 2a is equal to 8. Now what I'm going to write down is, clearly this is the simplest one, so I'm going to write over here that my 2a is equal to 8. And because my 2a is equal to 8, it's a linear equation, I can divide both sides by 2, and therefore a is equal to 4. And fairly straightforward. So I'm now looking at the next one, which is this one here, 3a plus 1b. And again, I compare it to its position in the numeric table, and 3a plus 1b is the top of the first difference table, so it's equal to 7. So 3a plus 1b is equal to 7. Now, I know what a is equal to. We've just worked it out. A is equal to 4. So 3 lots of 4 plus b is equal to 7. So 12 plus b is equal to 7. So b is equal to 7. I'm bringing the 12 over, so it becomes minus 12. So 7 minus 12, you should be able to do that in your heads. 7 minus 12 is minus 5. So I've got b is equal to minus 5. And now I've got the last thing I need to do, this one here. And it's a plus b plus c. And that's the very top of my term list. And the very top of my term list is 1, so I know that's equal to 1. I know the a is 4. I know the b is minus 5, and so there's my plus c is equal to 1. 4 minus 5 is minus 1, so minus 1 plus c is equal to 1. C is equal to 1. I'm bringing the minus 1 over, change the sign to a plus 1. So now C is equal to 2. So I've now calculated the A, the B, and the C. Okay. So am I ready to write down the nth term? Yes, I am. I know the formula for the nth term, because I've learnt it off by heart, is A on n to b squared plus b on n plus c. And I've just worked out what a is. And I know that a is equal to 4, so I can now write 4n squared. I know that b is equal to minus 5, so I've now got minus 5 on n. And I know that c is equal to 2. And the question is now, I've been required in the question to work out the value of T20. So I'm going to write underneath here T20 and ask myself, well, what does that mean? Well, that's term number 20, the 20th term. Or, using the comparison technique, it means I'm now replacing my n by 20. So here I've now got 4 on 20 to be squared minus 5 on 20 plus 2. Now if you want to reach for your calculators, then do that now. So you type into your calculator 4, you open the bracket, you press 20, you close the bracket, you raise it to the power of 2, you arrow on and type in a minus sign, you press 5, open bracket, type in 20, close bracket, add on 2 at the end, press equals, and you will find that term number 20 is equal to 1502. And you finished. But to play it safe, it might be a good idea just to work out term 1. Press the replay button on your calculator and delete where you had 20 and type in 1. Move your cursor along and delete the 20 and type in 1. And then press equals, and your answer on your calculator should be 1. And is that what you have up in your table? Yes. So you know you've got it right. Okay, you might be a little bit paranoid. You really want to make absolutely certain that you have got it right. So let's try and look at T2. What is T2? Well, T2, according to our table, is 8. So let's press the replay button now on the calculator. And we had 4 bracket 1, so delete the 1, press 2. Then move along to the next bracket, delete the 1, press 2, press equals, and you'll see on the calculator that you got 8, which means you know that you've got this entire question perfectly correct. You don't have to look up the answer in the back of the book. You know you've got it right. So that is how you derive the equation for a quadratic sequence. Now what I'm going to do now is I'm just going to change this to height view so that it's all on one page. So if you need to do a screenshot, you have it there. But to effectively learn from the example I've just presented to you, you need to be pausing the video from time to time and see if you can recreate it yourself and be absolutely clear that you understand it before you tackle any of the questions set in the exercise. Thank you very much. I hope you understand that and are able to generate the formula for quadratic sequences moving forward.